Okay, what was that, Michael?
It's because there's only one pair of threes, not two or more.
One pair of threes. Yeah, okay. Yeah. You have two ones, and one of the ones' output is a 3. The other one is a 4. So there's two outputs for that one input number. Now, just because that number occurs twice doesn't mean it's a different input. It's still the same input. Okay? If I put popcorn in the microwave and one time it comes out popped, the next time it comes out not popped, then obviously there's something wrong with my microwave. Okay? Or the loose nut on the keyboard, typing in the time, one of the two. All right, let's drop down. Drop down to number 13. Drop down to number 13. 13 says create an input-output table for the function. Use the values 0, 1, 2, and 3 as the domain. Okay? So, number 13 then, they want us to create an input-output table. Okay? They want us to create an input-output table. So I have my line down the middle. Then I have my X and my Y. And they have said that they want me to use 0, 1, 2, and 3. And they want me to use the functions that they have listed. Well, 13 says y is equal to 3x plus 2. So there's my function. They want me to plug in each one of those input values into my function. So this is how we would do that. We would take y is equal to 3 times 0 plus 2. Okay, my first input is 0. Okay, into my function. That would give me y is equal to 0 plus 2, y is equal to 2. Okay, so that's what goes in the output. Okay, so here's my output. Y is equal to 2 when I have my input of 0. All right, now you look at the next one. What would it be? What would the next output be if my input is 1? Matt Shelton, 5. Okay, what would be the next one? 8. Larry, what would be my last one? What? 11. Okay, now, if you can do it in your head, that's fine. The problem is, if you miss one, I won't be able to help you. Okay, if you need help going, I can understand where I got 5. Okay, well, I can't understand where you got 5 either for, input 3. Okay? Now, the other thing that you need to understand about functions, okay, most of the time, I really can't think of one where it's not going to be, your outputs are going to follow a pattern in the sense of, if this is increasing, it's going to increase, and unless this over here changes, in other words, if these all stay positive numbers, then this is going to increase as long as this increases. Okay? Now, it would change, obviously, if I put negative inputs in there, my values over here are going to follow a different pattern. Okay? But there's always that pattern as long as the pattern over here is the same. In other words, if I over here went 0, 2, 4, 9, okay, well, I can't go with the same pattern over here because in the end, it's going to be different because I went from 0, 2, 4 to 9. These all had, 0, 1, 2, 3, 4, 5, 6 would be the next one if it was going to follow this same pattern, okay? But most of the ones you're going to do, 99% of the ones you're going to do, are going to have an input to the inputs are going to, have some type of pattern to them where you can figure out the pattern for the outputs, okay? All right, let's move on. Let's see here. Everybody turn the page. I want to look at number 25. Look at page 50. I want to look at number 25. 25 says, a large apple tree may absorb 360 liters of water from the soil per day. Okay? You realize how much 360 liters are, right? Okay, it's almost, it's like saying 360 gallons. Okay? It's not quite, but it's, it's pretty close. Huh? 3.6 liters? You sure? Positive. Oh, is it? You read the milk carton, huh? Okay, then it's obviously like how many gallons then? No. 3.6 liters equal 1 gallon. Huh?
Still doing the math?
About 350.
I don't even care.
How much is it? I don't want you to explain it to me. I want you to give me the answer. Yeah.
Okay, so that would mean it's 360 times that. That'd be like about 9.
No. Thank you.
Oh, I get it.
It's 100 gallons. It's 100 gallons. Because if there's 3.6 liters in 1 gallon, as Matt has stated from the milk carton, okay, 3.6 liters equal 1 gallon. Okay, that's 100 gallons a day. Okay, that's how much an apple tree can absorb from the soil. Water from the soil is 100 gallons a day. So obviously, if it's not raining very much, then you're going to have to water those apple groves, a lot of water. Okay, obviously they're not just getting it from what you give in the soil on a day. Okay, so obviously you don't have to, but it is a lot of water. I didn't realize apple trees did that much water. Let's look at the input-output table. It says the amount of water absorbed over a short period of time is modeled by the function W equal to 360 Ds. Okay? All right, here's what I want you to do. You're going 1.7. We're doing 25 through 36. And then we're doing 53 through 58. 53 through 58. Okay, it's due on Monday. Don't thank me until you've actually looked at it.